Ladies and gentlemen, this section of workshop is about the forecast. We have 5 speakers. The first one, Bob Rogers from HRD. He's talking about the operational requirements for improving the tropical cyclone prediction and the forecast system. Please.
Okay, thank you. So what I'm going to talk about today are some efforts that we're undertaking in the United States to address one of Russ's comments, actually. He made a comment this morning about how the operational community and the research community, the university community, really do not interact well in terms of transitioning research advances to the forecasting system. So one of the things that we've been working on developing and improving in the past few years is a way to better facilitate that transition of research advances to predictions. So just a little background, motivation, of course, as is the case in Taiwan and elsewhere, improved tropical cyclone prediction is a national imperative. In the United States, our population within 50 miles of the coast continues to increase by as much as 50% over the past several decades. Also, the value of the infrastructure, all the houses and the businesses and things like that, the coastal infrastructure value and economic activity continues to rise to the point now where over $3 trillion US is accounted for within this region close to the coast. That's close to 1/3 of the annual gross domestic product of the United States. So obviously, there's a tremendous value and importance in terms of human lives as well as economic considerations for improving our forecast of tropical cyclones. So, of course, by having more accurate tropical cyclone forecasts and warnings, these can help reduce response and recovery costs. A more accurate forecast will lead to fewer false alarms and reduce the warning footprint, which can have important implications for unnecessary evacuations and then people not evacuating when they really should. So, the program that's been developed over the past several years, and that, again, we're trying to continue to improve, is a program called the Hurricane Forecast Improvement Program. Russ alluded to this earlier this morning as well. And several goals of the HFIP, which I'm going to call it. The first primary goal is to improve overall our forecast accuracy. This includes areas of track, where we hope to improve our accuracy by 50% over a 10-year time period, as well as the intensity forecasts. A 50% improvement in 10 years for that as well, which, as you'll see in a minute, is a very difficult challenge that we hope to be able to address. Also, we want to improve our forecasts of storm surge impact locations and severity of storm surge. So, one aspect we want to improve our forecast accuracy, but we also want to extend our forecast reliability out to 7 days. And finally, we would like to be able to better quantify and bound and reduce our forecast uncertainty to enable better risk management decisions by the public at large. So, these improvements that I talked about are very attainable, I think, in one case. Well, hopefully attainable in terms of track, but intensity, you can see it's going to be a much more difficult task to do. Our track forecasts have improved on average over the past 20 years or so by about 3% per year, to the point now where a track forecast at 48 hours is about as accurate as a track forecast was at 24 hours 10 or 15 years ago. However, if you look at these trend lines for intensity, you see much less improvement. Whereas track forecasts have improved by about 3% per year, intensity forecasts have improved by less than 1% per year. So imagine trying to extrapolate this out 10 years and get a 50% improvement or reduction in intensity error. It's going to be very challenging. So with that in mind, and with that knowledge in mind in terms of the operational community, the operational community, including the National Hurricane Center, which is responsible for forecasting hurricanes in the Atlantic and the East Pacific basins, has developed a set of operational priorities. What these operational priorities are what they think needs to be, what research that they would like to see conducted for improving various aspects of their forecast. And they have priorities here. They came up with 14 different activities or operational needs. And I'm not going to read all these, I just want to highlight some of them. But what they did was, again, that they identified which tasks they think are the most important that need to be addressed in terms of their forecast improvements. So just to summarize, the top priority that the National Hurricane Center came up with was intensity change, or intensity forecasting, and rapid intensification in particular. Also important are improved observations and what we call guidance on guidance, which essentially means taking a series of model forecasts and doing some sort of analysis with those forecasts to produce other types of forecasts based on those model guidance. So that's another high priority activity that the operational committee would like to see. Tropical cyclone track and genesis predictions have a medium priority in terms of what the Hurricane Center is interested in. And then rainfall, wind structure forecasts, and seasonal forecasts have a lower priority. Now, rainfall used to be much higher up in terms of the priority list, but it's dropped down. And the main reason for that is because the institution that's most responsible for rainfall forecasts from tropical cyclones is no longer the National Hurricane Center, but it's a hydrological prediction center. So it's not as high a priority now for the Hurricane Center, but it is obviously still important. And of course, these priorities will vary depending on which operational institution you're talking to. So the National Hurricane Center might have this list, but you can see, for example, JTWC, the Joint Typhoon Warning Center, which is responsible for forecasting the Western Pacific for the U.S. Navy, has some differences in terms of what they think is more important. The two top ones are about the same, but for example, they think Genesis is much more important for them, for their applications, for ship forecasting and things like that. So, and of course, and I think Russ alluded to this as well, I keep referring to Russ here in my talk, but I think he was saying that the forecasters, maybe at the CWB and maybe elsewhere, obviously put precipitation forecasting very high. So this list will vary depending on who you ask for. So one of the things that we've done in the past couple of years is to look at the research activities and really the research needs that must be accomplished to address these operational priorities. So I'm going to show you a table on the next slide, but before I do that, I just want to summarize the general categories that we came up with in terms of the research activities and the research needs. And these can be grouped into three primary groupings. What we call general research, which includes more sort of basic research type of activities, hypothesis-driven research to try to better understand the physical processes important in things like intensity and structure changes, tropical cyclone formation, precipitation, storm surge. So that's the general research category. The second category is what we call model development, which can include data assimilation research, physical parameterization development, diagnostics and verification, probabilistic guidance. All those activities fall under model development. And finally, the third category is what we call observations and observing strategies, which can include the development of new strategies and capabilities, the provision of observations for model diagnostics, which kind of fits in with this here, and the development of new observing technologies, such as unmanned aerial systems. So I'm not going to read all this, but this is what that table I just provided a summary of in its full form. So again, here's the general research category, intensity and structure changes, for example, looking at vortex scale processes, turbulent processes, convective scale processes, track forecasting, all these types of things for the general research. Model development topics, including, again, things like data assimilation, physical parameterizations, the impact of horizontal and vertical resolution, microphysical processes. All these types of activities are also very crucial in terms of addressing the operational priorities. And finally, the observations and observing strategies, new technologies, new strategies, OSCE type of work, observing system simulation experiments. All those are important research needs and activities that must be accomplished. So what we did was we took these